If we can do that, yeah.
Yeah.
Do you want me to ask? Why don't you go ahead? I'll let you.
Yes, we have the room for most of the day. We have a lunch reservation at 12, just across the courtyard. So we can do one more talk, break for lunch, and then come back. And I think we have a meeting at 1:30, so we should be able to get the last 3 remaining in before then. Any sound good? All right.
Okay, thank you. Yeah, apologize about running behind. So our next presentation is Karthik Chandrasegaran from GlobalFoundries in Malta, New York, my hometown area, and he's going to talk to us about the progress and announcement of their open source PDK for 180. So, Karthik?
Thank you, Rob. Can you hear us? Can you hear me properly?
Yes.
Okay, thank you. Thank you for the invitation to talk. Today, I wanted to talk a little bit about the GlobalFoundries 180 MCU open source program, a little bit about what our plans are for open source and why we're really doing in this, engaging in this open source project. So first, just to start, I don't know how many of you know about GlobalFoundries, but I wanted to, this is a chart that we show to a lot of our customers where foundries are essential part of what the entire ecosystem today is. If you compare together what the global GDP is at 89 trillion, about more than close to 3% of it is driven by electronics. And about 3% of that is underpinned by just 5 foundries of scale today. That's almost like the 5 foundries which have a market size of about $96 billion are actually driving about 2.2 trillion of this. This became more apparent during the pandemic as we went through shortages and things like that. And that's one of the key things. Foundry forms a significant part of the ecosystem. And foundries are growing at about 6% CAGR compared to what the global GDP is growing at. And GlobalFoundries, as the name suggests, by itself, it's truly global. If you look at it, we have like a significant footprint spread out across the world. Of course, in the US, we have our Malta, New York facility, which has like significant capacity. We do have Singapore, we have Germany, we have Burlington in the US, and also an upcoming facility in Crolles in France in partnership with STMicro. And in terms of technologies as well, GF, just to give a perspective, we're not in the race for single node transistors. We pivoted at 12 nanometer, but we have a wide range of things that is purpose-built, what we call as purpose-built platforms for a wide range of applications, from feature-rich mainstream CMOS devices, high voltage, power management, embedded non-volatile memory devices, to FinFET, which is our 12 nanometer platform. We do have a unique FDX, which is our fully depleted SY solution. And then we do have a wide range of partially depleted SY solutions, which are very unique in RF, low power, low noise, low latency, high frequencies. And also, we are the market leader in silicon photonics today, especially in 300 millimeter. We have a unique photonics platform, which is actually one of the best today, best in class in the industry. We do have significant capacity in our Burlington facility doing silicon germanium still, which win in the power amplifier and very high frequency application. And last, we are also investing and we continue to grow our gallium nitride business. So we have a very strong feature-rich platform that is part of our platform. And to talk about why GF is doing open source, when we decided to do open source, we had 2 things in mind. One was, again, startups and small companies. Today, they cannot afford to do ASICs as such, because given the volumes they're doing, for the volumes that they have, for EDA and IP costs really is a big limiter for them to be able to amortize that across very small volumes. And really, they are today buying off-the-shelf parts or doing it on FPGAs, things like that. And this is really something that open source, we think, opens it up. And in the later few slides, I'll talk a little bit about even how our long tail of customers are starting to see this as a very viable option if they do not have to have this significant cost for IP and EDA. And the second one is, again, Google is an example where we do see large companies who see open source as a way to accelerate innovation and customization. They're doing various things using open source tools to be able to accelerate innovation, which are not possible without having access to an open flow where they can customize and use unlimited number of licenses, things like that. So we are seeing test cases on both sides of it. In the initial phase, I think this would be the key customer base that we would be attacking. In terms of open sourcing GF technology, we started with our 180 nanometer. In our current state, all our technologies require our customers to have NDAs in return for PDKs, reference flows, for them to work with our IP and EDA partners to get access to it. And GF 180 MCU, thanks to Google and eFabless and everybody, we have like a complete open source platform today. And this was released by Google and eFabless as open source in August 2022. So 180 MCU, I do want to stress, is the first technology in our roadmap. We haven't officially made announcements on the other ones, but yes, we do plan to continue to work with Google to build a complete roadmap that will be made available to the wider community. Again, thanks to the team, MPW0 submissions closed in the first week of December, and we were given even a short window and a short time frame for us to do designs, for designs to come in. Thanks to all the hard work from Google and eFabless, we were able to get up to 90 designs. And based on current plans, we do plan to send the wafers back to eFabless and Google by March of 2023. Hopefully in time to get it back to the entire community back sometime in April. To talk a little bit about our 180 MCU solutions as such, why did we choose 180 MCU as such? If you think about it, we have like a large corridor in Singapore, which is our GigaFab. We ship about more than 1 million 200 millimeter wafers today. And MCUs and general purpose compute, analog power ICs dominate a significant part of that market. And we're talking about like 8-bit MCUs, 16-bit MCUs, very, very low-end 32-bit MCUs, which go into small home appliances, touch control, remote control toys, audiobooks, battery management, etc. Right? Same for analog power IC, small audio amplifiers, battery protection, charge pumps, DC-DC converters, LDOs, LED drivers. And these are significant volume drivers even today. And you would be surprised how many wafers get shipped for all of these. Just toys, for instance, they ship millions of wafers just for toys. So it is a big market, and the requirements for these are still very, very simple. There are people out there even shipping 8051 microcontrollers, 8051 based microcontrollers in significant volume as of today. And this shift is slowly happening to very low power, optimized 32-bit microcontrollers and things like that. So this is a very sweet spot, and it's a very cost-effective solutions, especially looking at where we are attacking in terms of open source tools and for people to go innovate and try things. In volume production, today, a single gate oxide, with a single gate oxide, we can achieve 3.3 volt and 5 volt, and it only requires 14 masking layers. This is with a 3 metal layer as baseline, and this requires only 14 mask layers, which means faster turnaround time, cheaper in cost for our customers, and getting on an MPW shuttle is like so cheap for them to go test their designs and go to full volume production. And the mask costs are sub 100K for them to even go into full volume production, which kind of makes it a sweet spot for them to be able to, even at a lot smaller volume, to be able to make ASIC as a very possible option. And it's extremely design friendly with extensive design offerings and very compact IP solutions. We have standard cells, memory compilers, eFuses, IOs, OTPs, MTPs, all of these available as part of the platform. Right. This is a busy slide. I don't want to go through every detail of it, but 180 MCU with a single work function, single gate oxide, we can achieve both 3.3 volt and 5 volt offering. And in terms of rules, today our first MPW shuttle was predominantly targeted at 5 volt, but we're working with Google to see how we can enable 3.3 volt for the further along for the next MPWs. Especially one of the few advantages, as you can see, the SRAM cell size drops dramatically. In the bottom left, if you can see, cell size drops to about half. It's about like 6.96 micron square on a 3.3 volt cell compared to a 180 MCU 5 volt, which is at about 13.5 micron square. So you're going to see very small in terms of memory macros to generate those arrays as you get down to this. So that's one area we're trying to get down to it. And of course, with the 3.3 volt, you're going to see significant improvement in your dynamic power, while your static is almost very close to what the 5 volt does. And line spacing, area spacing as well, you get like a certain amount of shrink. So you should be able to get a little bit more area on it. And those are exact reasons why we're starting to also enable 3.3 volt, maybe in the very shortly. We do offer multiple different backend options depending on what the ask is or what the requirements are. There are other options in the technology as well in terms of memcaps, poly high resistors. All of these are offered as part of this standard package. In terms of platform IP solutions, I know initially, currently, we only support GlobalFoundries maintained standard cells, and we also have Professor James Stein's OSU's standard cells also available as the 5 volt. But as you can see on the top right, there is a wide range of third-party ecosystem partners, whether it's eMemory, M31, YMC, who have like standard cells, memory compilers, IOs, eFuses, OTPs, MTPs available in it. Google has started engagement and discussion with some of our wide range of ecosystem partners, and there's a lot of interest in bringing these IP to the open source as well, which is a big dynamic shift in what the industry is going to start seeing. So maybe in the next future, we're going to see 3.3 volt standard cells and memory compilers from our third-party IP, as well as like OTPs and MTPs be made available to the community shortly, right? And here also we've compared some of the standard cells and memory compilers between different, the 3.3 volt and the 5 volt. The 3.3 volt, given we also have a 11-track library, in terms of gate density, it's comparable to the 5 volt. But again, because of the lower voltage, you're going to get a better power with the same kind of density. On a memory compiler, definitely you're going to get less than half the area of what the current memory is offered. And also the current memory is more like we release 3-4 instances. You're also going to get a compiler capability with the 3.3 volt, wherein people would be able to generate their own compilers. The IOs are also going to be able to available in a much smaller IO height compared to what is currently available, right? And the OTP and MTP solutions are also something in discussion, and hopefully they should be made available sometime in the first quarter. As we go through this, and given the wider community here, I do want to discuss a little bit as we are discussing our commercialization strategy within our business units, our sales teams. What does the ecosystem need? So we are, one thing I do want to make sure that everybody understands is commercialization of open source is getting closer. We are talking directly to our customers, and there are customers out there who have given us a list of things that they would like to see, but they are getting closer to making open source tapeouts, using open source, complete open source tools and IP, maybe as early as 2023. So there is a long tail of customers are considering this as a very viable option. And the ask to the community is, for any customer who's doing a commercial tapeout using open source tools, definitely requires a support model for EDA tools. It's one thing that we do know about hardware designers, which is slightly different than software designers, is there is a big threshold for them to get everything right in the first time because of the lead time, the costs involved in terms of mass and everything. Tools can be free, but we definitely need someone who can provide support as a service for the various tools. This is definitely a requirement because the more we talk to the community or our customer base, customers are asking, that's fine, but when I run into an issue in the tool, I can go file a GitHub request or go on a Slack channel, but they do want to be able to file a bug somewhere or buy services from someone who they can talk to and is able to fix these tools. So we do see this as a must requirement for us to be able to provide open source EDA tools to become commercially viable. Again, the next one is open source IP. Thanks to Google and Google's MPW sponsored shuttle program, as well as like the eFabless Chip Ignite program, open source IP is getting developed at a rapid pace. We do see a lot of IP titles and various things getting developed. And for the previous talk, like Professor Mehdi talked about, like all the interesting things he's doing. how do we make them ready for commercial takeout, right? We do need, like, I know a lot of the IP is available out there. People can go access it. You can find it, but we do need a catalog or a marketplace to aggregate all the IP. We do need standardization of documentation, standardization of how design collateral is maintained, how the .libs are, everything is available. The GDS is provided. All of that needs to be done. Version control with bug fixes, improvements, all the silicon reports being available at a certain part, and any inputs on where if these IPs have been used in commercial in products and it's been silicon proven, all this needs to be documented. So we do need a way for certain all these to happen. Ideally, a support model or companies and startups evolving who are able to take this open source IP and create this marketplace and ecosystem where also provides services for customizations, integration support, silicon debug needed as a support model, as a service. This is something that will be required if we'll have to make open source IP as a reality to be commercialized. There are customers who are willing to take it at risk, try it in an MPW, but realistically, given the lead time and all of it, some amount of ecosystem evolving around it is required. And the third part of the ecosystem that we are getting inputs from customers is they want dedicated skilled resources who can provide design services. It doesn't have to be a complete design, someone to take a complete design and provide all the way from RTL to GDS, or provide services in Verilog, or provide services and things like that. But we're hearing from people that they might require specific things like, do I have a skilled resource that I can hire for a few months who can provide CAD support with all these EDA tools? Because we do not know how to get this entire CAD setup done. Can someone help us with providing just timing closure to make sure with these open source tools how everything works, do a timing sign off and all of that stuff. So all these kind of things are required. So we are hoping a vibrant ecosystem is what will be the final step in making open source a reality for commercialization. And we do request the community to step up to help in these regards. This is one last slide that I will leave you with. And really, one of the future state that we enabled with open source, we do think is an easy way for people to be able to access and do business with us. We do expect that in the short run, not very far away, we do expect all these information is available on a cloud with open source PDKs, open source IP, as well as some commercial IP being available, design flows being available, on-demand compute, even pricing information being available to everyone, including wafers, services, EDA, if it's a software as a service, compute, all of it. And whether it's open source tools, as well as like a mix of commercial tools required in the flow, all that is available, and people with no human interaction as a very low touch model being able to design and order wafers. This is not very far from reality. We do expect this to be enabled not too far away. That's kind of everything I had. Thank you.
Thanks so much, Karthik, for a great chat. Any questions from the audience here or online? Oh, we have a question, Mehdi.
Thanks, Karthik, for the presentation. I have a couple of questions, actually. So the first one is, do you have memory compilers that